Today we are going to learn all about applications of sinusoidal functions. So here we go. The first example says this: the weather in a town is given by the following formula. T equals 27.39 times the sine of 0.54 times m minus 3.76, where T is the temperature in Celsius and m is the month number. And the way that works is January is 1, February is 2, etc. And we're talking about the year 2006. So 1 is January of 2006 and so on. What's the median value of the equation? 0. So that's the answer to part A, is it's just 0. That's the D value, so it's 0. What's the amplitude of the equation? 27.39 degrees Celsius. What's the period? What's that? Nope. Good try. How do we find the period? Two pi divided by b, and in this case b is 0.54. So what do we get? What's 2 pi divided by 0.54? What's that? You're right, but what is it numerically? We'll have to dig out our calculator to find out a numerical answer for that. What's that? Nope. No, if you're going to use your calculator, make sure you go 2 times pi and then divide that by 0.54. 11.63. That sounds good. So that's the period of the equation. 2 pi divided by 0.54. 11.63 makes some sense because 11.63 is about 12, and typically weather is periodic in the sense that we expect the same temperature in June every year, give or take on average, and we would expect temperatures in November to roughly be the same on a year-to-year basis as well. Okay, so that's just taking the equation and trying to interpret it a little bit. Now, move on to the next example. Here, it gives us just a graph. It doesn't give us an equation, but we are going to try and answer some questions on this graph. The value of an investment on the stock exchange is given in the graph below. January 2006 represents month 0, February 2006 is month 1, and so on. What are the minimum and maximum values of the investment during the 13-month period? Well, the minimum value is negative 500, and it happens in September. And the maximum value is 3,500, and it happens in March. Okay. What month does the investment begin to drop in value? So is it going down? Well, it's March. After March, it begins to go down. So when it reaches that maximum value, after March, it begins to go down. At what month does the investment reach a value of 0? That would be, it's in July. It's between July and August. So it's in July where it happens. And how many months is the investment losing money? We assume it's losing money. If I was to wordsmith this question, I would actually say that the y-axis represent whether the investment was gaining or losing money. And if I was to do it that way, then B and C would kind of become the same. And I think if you look at it that way, then we can look at D, which is how many months is the investment losing money? Well, the investment is losing money, if we look at it that way, between here and here, which is how many months? Between 7.5 and 10.5, it's 3 months. Or, yes, 3 months. That's why I said I will probably rejig this question for next time. But that's how we go about and do that. Sure. A is just what we did up here on the graph. And I'm not a huge fan of A, to be honest. Like I said, I would kind of take a slightly different approach with this question, which would possibly nuke part of this question now that I'm looking at it again. But that comes from experience of making better questions. So let's get on to a better question. Here's a really good question. It's a Ferris wheel question. Ferris wheel's pictured below. A complete ride makes 5 revolutions. So in other words, you hop on the Ferris wheel and it's going to make 5 complete revolutions. And those 5 complete revolutions altogether take 1,000 seconds. We're going to assume that the loading point of the Ferris wheel is at the bottom. Part A, find an equation that models the height of a passenger on the wheel if they start at the lowest point. And then we're going to do part B, which is how long is the Ferris wheel? 10 meters in height. And we'll say, or higher. Okay? To answer part A, really what we're going to try and do here is we can either do one of two things. We can take the information that's given in the first paragraph and we can make a table out of it, or we can graph it. Either way. But we have to take it and interpret it somehow. We could do a table because tables are easier to make. Okay? If 5 revolutions take 1,000 seconds, then 1 revolution is going to take how long? What's that? Yeah. So at 0 seconds, when the ride begins, the height is 1.2 meters because it's the bottom of the wheel. And we know that because the diameter of the wheel is 12 meters and the height off the ground from the top is 13.2. So if you subtract those, you get 1.2 meters. Here's what we also know. We know that at the end of the ride, that's 200 seconds, it'll be back at 1.2 meters. What else do we know? Well, we know that at the halfway point, it'll be at the highest point. The halfway point's 100 seconds, and the highest point's going to be 13.2 meters. The missing parts of the table are going to be where the graph hits its midline. It's vertical midline. What's the vertical midline going to be for the height? Don't just guess. This one's a little bit trickier than you think it might be because of decimal points involved. What's the midline going to be? No. No. What did I say? Don't guess. Nope. We want the exact middle. We can't be close. Just also remember that's 13.2 and 1.2. No. A lot of guessing going on. No. You want to find the middle. What's that? Thank goodness, Malcolm. 1 point, we add the two. You want to find the middle of anything. You want to find the average of anything. You add the two numbers together, you divide by 2, and you're going to get 7.2 meters. Okay? So that means that we're going to be at 7.2 for both of these. And how many seconds is the first one going to be at? 50? And how about the second? 150. So now we have values. We have a table. Okay? Now, whether we're using Desmos, and I've said this a few times, whether we're using Desmos or the graphing calculator, but I have to be honest with you. Desmos sucks when it comes to sinusoidal regression. So it's graphing calculator or bust today. So you got to use your graphing calculator when we're doing these questions because Desmos butchers the period when you're dealing with sinusoidals. It just does. Desmos is an amazing tool. I'd recommend it to 100 out of 100 kids, but it doesn't do this particular stuff well. So we shouldn't use Desmos. So it's graphing calculator time. We're going to go stat, edit, clear your lists if necessary. Excuse me. You can go to the clear your lists command through the memory tool if you wish. We're going to start at 0, 50, 100, 150, 200, 1.2. Oops, 1.2, 7.2, 13.2, 7.2, 1.2. You got your 5 points. You do need 5 points for a sinusoidal. Of course, if we're using the graphing calculator, you got to come up with an appropriate window. And the window is dictated by your values. So I'm probably going to go from about -20 up to exactly the 200 seconds. For my height, I go up to 13.2. So I don't know, like -1 up to like 14, I guess. Oopsies. I don't know what the heck I'm doing here. Boy, I think I'm just wishing I was in weekend mode. It's -1 to 14, and we'll go up by ones. If you have any existing equations in your y equals, you're going to want to clear those existing equations so that we can see a nice clear picture of the graph. I think I buggered up my points by looking at the graph. Those points look good. I think my points on my stat edit though are not good. Oh, I just made a mistake here. That should be 13.2. I think I typed in, it just didn't hit register. At least that's what I'm going to tell you anyway. Now, I'm going to go to my y equals. I'm going to clear the equation that's there and then hit graph. And when we hit graph, we'll see a nice, and it's hard to see that and think of that as a smooth curve because it kind of looks like a triangle, but it would be a smooth curve that goes through those points. See what? What's that? Nothing. Nothing should be there. No, we're not doing anything yet like that. We will be though, but not yet. All we should have right now is your points entered into your stat edit, an appropriate window set up so that you can see all 5 of your points. Once you have that, then we can go ahead with the regression part of this. Okay? So let's think about the regression here. We're going to go to the home screen. And when we're at the home screen, you're going to go Stat, Calc, and we're going to go ahead and use Sine Regression. It's the third from the bottom. It's option C. It asks for the number of iterations. Iterations tell you the more iterations, the more accurate it's going to be. Yes, Julie? Come here. Your stat plots aren't on. Now they are. You're just missing your last point, your middle point. The more iterations, the more accurate it's going to be. I would just leave it at 3. Your X list and Y list should be L1 and L2. It asks for what the period is. If you know what the period is, you can answer it here. What's the period? Anyone want to guess here? What's the period? Not really a guess. Do we know what the period is? 200. Okay? It's 200. Let's leave that blank. You're right, it's 200, but let's leave it blank. We're going to go vars, y vars, function y1 here. And let's hit calculate. Let's see if we can do that without entering the period. And we can. That's what we get right there. That gives us our equation right there. I'm just going to go and take a screenshot of that because I want to just paste that over here. So that's your A, B, C, and D value for sine regression. Okay. That's your A, B, C, and D value. Yep. Well, it's not only different because it's plus C, but it's also different because it's bx plus c. The equation we dealt with was b bracket x plus c. This is bracket bx plus c. So I'm going to be honest with you. The real c value, like the real c value that we care about, is actually going to be the c value here divided by b. So you have to actually take the c value that's here and divide it by b to give us that. Plus, we'd have to take the opposite sign because we deal with the negative as well. Okay? Now, once we have that equation stored in our calculator, when you report the equation, by the way, when you report the equation, you cannot report it saying A equals this, B equals this, C equals this, D equals that. You have to write out the equation with those numbers, okay? And you have to do it to a minimum of 2 decimal places. If you just leave it as A equals this, B equals that, C equals that, D equals that, that's a half mark deduction communication error. So you could write it as Y equals 6 sine. I'm fine if you write like this, 0.03x plus, actually not plus because that's minus 1.57 plus 7.2. That's fine. That's fine. But you can't do it any other way. Like you can't just leave it as A equals this, B equals this, C equals that, D equals that. Now we can answer the rest of the question, meaning how far is it 10 meters high or higher? Well, we go back to the graphing calculator and actually first I'm going to do this. I'm going to go Desmos because I want to show you why Desmos doesn't work sometimes for this. Just watch. And it's a shame too because Desmos is awesome, but because we can make the equation be what we want it to be. Y1 is approximately equal to A times sine B bracket x1 minus C plus D. Oh, I see. We need another bracket there. Need another bracket there. See, the problem with that's the problem is it just goes nuts. It just goes nuts. Now, if we said something, I think you can say something like B. We know what B is, right? B is well, that's the problem. That's the problem. Oh, there we go. Is that better? No, because it's saying that it does a, yeah, no, it's still not good because it's saying it does a complete period in about five seconds, which is obviously wrong. So that's why we can't use Desmos. Okay? It's a shame. This is the one spot where Desmos doesn't work. So the question does ask, how long is it? Well, let's just see how the equation fits that data. Oh, wait a second. Does the equation even fit the data? Uh-oh. Uh-oh. Uh-oh, let me go to mode. Ha! Okay. Calculator has to be in radian mode. If yours was, good for you. Mine wasn't. So what that means is I just have to do this again. No, there it is right there. I still get the same numbers, but now I hit graph, and now it does this. Now look at that beautiful curve, that beautiful sine curve that graces each of those points beautifully. There we go. So the equation's the same, and it just goes through those points so nicely. Okay, there we go. But how long is it 10 meters higher or higher? We create with second equation. Y equals 10. We hit graph, and we need to find the intersection points. Second, calc, intersect. We will leave the cursor somewhere around the first intersection point. And the first intersection point is at 65.45422. So we're going to record that number there, 65.45422. And then we're going to find the second intersection point. So second calc, intersect, but we're going to go ahead and move the cursor so it's close to the second intersection point, and the second intersection point is going to be 134.54548. 134.54548, I think it was. Let me double check that. Yes. Those are the two times at which the Ferris wheel reaches a height of 10 seconds. So what we need to do is we need to take these two numbers and subtract them. And when we subtract these two numbers, that's going to give us the time at which it is 10 meters or higher off the ground. So what we're going to get is 69.09. Is it 69.09 when we round to two decimal places? Yes? What comes after the 9? What's that? Okay, yeah. So it's 69.09 seconds. So in one revolution, it's above 10 meters for 69.09 seconds. Okay? All right. Next example. We're given data here, and we are asked to go ahead and graph it, and then go ahead and do all this other stuff. I'm going to skip this question because I don't really, I've emphasized this before. When you graph things here, typically 3 marks on the exam, if you're asked to graph something, is going to go something like this. If you're given data like this, 1 point will be if you graph the points accurately. And if you do graph them accurately, you're not going to be graphing like 18 points like you are here. You'd probably be graphing 6 to 8. You're going to get 1 point for writing appropriate scales, like labels and units on the axis, and 1 mark for appropriate scales. In other words, your x-axis has an appropriate range, your y-axis has an appropriate range. So I'm not going to go over this question with you just because it's a pretty straightforward question. And with that, we are done the lesson. There is some information on how to do it on the graphing calculator here. But just as an aside here, it does add that, and this goes back to the conversation earlier, the graphing calculator gives us the equation bracket bx plus c. So to change it into the form we use, now we actually use the minus c part, but you have to take out b as a common factor. So your c value will change when you do that. And so if you're talking about, if you're graphing your equation that you find, it might be useful to take out that b value as a common factor so you can have the proper c value, which will tell you how far to move it left or right, because you don't have that proper c value with the equation that the graphing calculator spits out at you. Okay? Now, I won't end this lesson now. What I do want to do is I want to find a question from a recent exam, and we'll do that together on the stuff. Because whenever we've come across these questions, my stock answer has been, I'm not going to talk about that. So let's find a question, and we'll start with, we'll see if there's a, actually that's not what I wanted anyway. Let's see if there's a decent one on January's exam. I don't know if there is, but we'll see. No. There we go. Perfect. Done. We'll do this question here. Question. So this is the the January 2017 exam. January 2017. Okay? All of you should have, I gave you that exam at one point. Okay? Okay. And what we'll do is I'll throw it up on a smartboard and we'll answer this question. And the reason why I want to do a question from an old exam is to give you an idea of what type of questions you should expect when you do the exam. And this is the most recent exam. So obviously this is a fair game question to expect on the exam. 2017, the most recent exam. Okay, Malcolm, do you have it? So if any of you want to look at the question face to face, you can move closer to Malcolm. I'm sure he'll share. Here's the question. Stephanie experiments with the frequency of waves in a ripple tank during her physics class. At the beginning of the experiment, she places a ruler into the tank and measures the median height of the water to be 10 centimeters. Now, what a ripple tank does is it causes vibrations in the water. So if the water is still at a height of 10 centimeters, the water, like waves, it's going to go up. It's going to come down below the 10 centimeters, and then it's going to come back up. The key thing here is to understand that the median height of the water is 10 centimeters. The water then rises to a maximum height of 13 centimeters at 1 second. Determine the sinusoidal regression equation that models the relationship between the height of the water and time. Show your work. What's that? We could, or we could use a graph and go that way. So here's when I tell you something that's probably going to make you either really happy with me or really unhappy with me. All the stuff we've done in the trigonometry unit up to today, I don't want to say it means nothing, but it doesn't mean as much as what we did today. The types of questions you're going to see on the exam are almost exclusively like the ones we're doing today. But in order to understand the ones we're doing today in class, will be more like the ones on the exam than any of the other ones from any other day in this unit. The problem is that we have to kind of go through the process of understanding stuff like period. Well, you do have to understand that stuff. Period, amplitude, finding the maximum height, finding the minimum height, working with equations, even graphing them. All those things are useful skills. But with the questions we're doing today are going to be what you're going to see on the exam. Again, I can give you an equation and you have to graph it or answer some questions on it. Or you could be given a table of values and you find an equation and then you do the other stuff. Or you're given a context. That's this question. You're given a context. Then you have to generate the data, and then you have to go ahead and find the equation and do stuff with it. This type of question is the hardest type of question I can ask you in sinusoidal modeling because there's no equation, there's no data. We have to use the information, come up with data, come up with an equation, and then answer the questions. So we can do it with a table or we could do it with a diagram. It doesn't matter what we want to do. We could do either way. So let's start. We could do a table, as Malcolm suggested. So here we go. It's a 2-mark question. 1 mark will be for your work, which is the table, 1 mark for the equation. At 0 seconds, it's at a height of 10 centimeters. At 1 second, it's at a height of 13 centimeters. At 2 seconds, it'll be back down to 10. At 3 seconds, it'll be down to 7 centimeters. And at 4 seconds, it'll come back up to 10. So there's our table. There's your work. Okay? Now we can use that to go ahead and come up with the equation. Just type that into the graphing calculator and have it come out with the equation. Now I'll tell you what though, guys. Here's what I'm going to tell you. If you understand sinusoidal functions, you don't even have to use the graphing calculator. Because I'm going to ask you a question. What's D? Yeah, what's D? 10. What's A? 3. See? So we can figure out D and A without even hitting the graphing calculator. We can figure out B and C the same way. And that's why I said, even though today is like everything we need to know about sinusoidal functions for the exam, it's all these previous skills that we've learned previous to today that helps us answer these questions. Now, there's nothing wrong if you want to, and the majority of applied students will probably just punch this into the graphing calculator and find the regression formula, and there's nothing wrong with that. But we do have the skills to do this without that, because like we just said, D is 10. A is 3. Okay? Then we got to figure out B. Well, B is, well, what's the period? The period's going to be 4 seconds. So here's what we know. B is always equal to 2 pi over the period. So it's going to be 2 pi over 4. Now we can figure out what 2 pi over 4 is, or I can just leave it as 2 pi over 4. Okay? I can just leave it as 2 pi over 4 if I want. Or I can leave it as pi over 2, doesn't matter. Okay? And C, well, think about this. The height starts at the midline, it goes up to the maximum, it comes back down, it goes to the minimum and comes back up. Yeah, C is 0 because it starts where it needs to start. So again, without even touching regression, the equation for this formula is going to be 3 sine pi over 2, if you want to write it like that, x plus 10. And we didn't even have to use the graphing calculator to come up with that equation. But again, I'm going to state the obvious. If you find this confusing, then use the graphing calculator. Let it do the hard work. You've got a 3-hour exam to write next week. If you're in the exam and you get a question like this, throw in your calculator. Let it do the work. Don't do any extra thinking if need be. Because let's go ahead and do the graphing calculator, and you'll see that we get the same answer. So we're going to go stat, edit, and we have 0, 1, 2, 3, 4, and 10, 13, back to 10, down to 7, back up to 10. We'll quit out of there. We'll go second entry so I can cheat a little bit and just figure out what that equation is. And that's how we get right there. Those values are identical to the values that we just got. A is 3. Yep. D is 10. Yep. B is 1.57, which is pi divided by 2. The one thing you might ask me is, what the heck is 3.71 blah, 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 blah? Well, scientific notation, it says times 10 to the negative 13, which means that number is pretty darn close to 0. So we're good. We're good. Okay? Once again, if you want to use the graphing calculator, go ahead. There's no, it's not like if you use a graphing calculator, there's nothing lost here. But if you could do it without the graphing calculator, then that's good too. Question, Malcolm? Yes, because we record it to 2 decimal places. So to 2 decimal places, that's 0. Only if we were writing this to 13 or 14 decimal places would there be something that wouldn't be 0. Okay, so that would be 0. No, any any e value that's negative and is probably -3 or higher. And when I mean higher, I mean like -4, and I understand that's actually not higher, it's lower, but -4, -5, -6, -7, -20, -30, -40, -50, -60. That's 0. Okay? Okay? So again, we can do this on our own, or we can use this with the graphing calculator. We just got to do it. Now, I am going to set an appropriate window, or maybe I'm not. I don't know. Let's see what the question says here. Question says, what's the height of the water at 15 seconds? Well, here's an interesting question, guys. Again, this is a pretty cool thing. If we understand periodic functions, I'm going to tell you something. You don't even need the graphing calculator. I'll tell you why. What's the period? No. What's the period of this graph? 4 seconds. After 4 seconds, it's done. Okay? So here's the thing. Keep in mind 15 seconds. After 4 seconds, it's a period. After 8 seconds, it's a second period. After 12 seconds, period number 3. How many seconds after 12 seconds is 15 seconds? 7. Now, if you don't believe me, let's go to the graphing calculator. Let's go second. Let's go second table set. X equals 7, or rather, sorry, 15. And go second, oopsies, second table. What do you get? 7. So the height at 15 seconds is 7. So we can use the graphing calculator to find out the height at 15 seconds. Or if we understand periodic functions, we know that 1 period is 4 seconds. So 2 periods is 8 seconds. 3 periods is 12 seconds. And then we just have to go 3 seconds beyond a period to find the height at 15 seconds. The wonderful thing about applied math versus pre-calculus. Pre-calculus is a very good math course to take if you're inclined that way. But pre-calculus is boring in a sense because there's only usually one way to solve a problem. Applied math, there's lots of different ways to solve problems. Applied math is more about problem solving. And here we can do it with technology or we can do it otherwise. It's a 1-mark question here, which means we don't need to show work. We just need an answer. So it is 7 centimeters, not meters. That's going to be really tall water. 7 meters is like 4 of me. Part C is an interesting question. It's a thinker. It's going to require a very concise answer because it's an explanation. Stephanie changes the settings of the motor to generate waves more quickly. Write an equation that can model the change if all other conditions remain the same. So if waves are being generated more quickly, let's think of the letters A, B, C, and D. Which of those letters is going to change? B. And is B going to become bigger or smaller? What's that? Um, it's going to become bigger. When it becomes bigger, the graph goes like this. So there's going to be more frequent waves. So B will get bigger. So B just has to be bigger than pi over 2. So it could be pi, sure. So it could be y equals 3 sine pi x plus 10. Okay, but just a second. B is bigger, so now it's 2. Period's 2. Yeah, that would be good. Okay, so that's an example. That it says write an equation that models the change if all other conditions remain the same. So that is one of the toughest questions that we can ask in relations and functions because there is no data and there's no equation. There's a context. You have to create the data and then create the equation using your knowledge of functions or using the regression tools on your graphing calculator. Sure.